Covalent bond. The bond formed by the mutual sharing of electrons between the combining atoms is called as covalent bond. Okay? The bond formed by the mutual sharing of electrons between the two combining atoms is called as covalent bond. Example, covalent bond. Example, chlorine molecule, Cl2. Here the chlorine atom contains 7 electrons in its shell. So it needs one more electron to complete its octet. Okay. So both chlorine atoms shares one electron each for bonding. Let us draw the Levy structures of chlorine atoms. Okay. Here also one. So 7 valence electrons. Chlorine contains 7 valence electrons. Okay. So one electron will be contributed by this chlorine and one electron will be contributed by this chlorine. So these two electrons will be at the center. These two electrons are shared by both the chlorine atoms like this. Okay. So this type of bonding is called as covalent bond. Okay. Chlorine molecule. So, chlorine molecule is obtained. Like this, a bond is formed. If two electrons are shared, then such bond will be a single covalent bond. Okay, this is single covalent bond. If two pairs or 4 electrons are shared, then the bond obtained will be double bond. Okay, if the 6 electrons or 3 pairs of electrons are shared, triple bond is obtained. These double and triple bonds are commonly called as multiple bonds. Let us take few examples. O2 molecule. Oxygen contains 6 electrons in its outermost shell. Okay. So, here 2 electrons shared from this oxygen atom and this oxygen also contributes 2 electrons. Okay. So, this will get an octet of electrons by sharing 4 electrons. Here also this oxygen also shares this chlorine, this electrons. So, the bond will be O double bond O. Now, N2. Nitrogen contains 5 valence electrons. Okay. So, 3 valence electrons are contributed by this nitrogen atom and 3 electrons contributed by second nitrogen atom. Okay. Total 5 valence electrons. Okay. So, 6 electrons are shared at the center and bonding will be like this. So, N triple bond N. A triple bond is obtained. Then let us take another example, C2H4. Carbon. 2 carbon atoms. Four valence electrons for each carbon atom. Okay. 4. Then hydrogen atom contains 1 electron each. Okay. From here, this carbon shares 1 electrons. Here also, carbon shares 1 electron. Okay. Now, what about this carbon atom? This contains, this shares this 4 carbon atom and these 2 carbon atoms from here. So, total 4 plus 4, 8. Here also the same. Okay. So at the center, two pairs of electrons are shared. So same double bond C will be obtained. And the structure will be like this. C double bond C. Here single bond. Here single bond. Okay. Like this. So C2H4. Like this, single bonds, double bonds and triple bonds are obtained due to the mutual sharing of electron pairs. Okay. Next, let us discuss some important points while writing the Lewis structures in covalent bond. First point, total number of electrons required while writing the Lewis structure are obtained from the valence electron of the combining atom. Okay. Total number of electrons for writing the structure of or Lewis structure is obtained from the valence electrons of combining atoms. Okay. Then second point, for anions, each negative charge represents addition of one electron. Okay. For cations, each positive charge represents subtraction of one electron. Okay. Then third point, depending upon the bonds, here we can write examples. In the case of CO3 2 minus means 2 electrons are added into the compound. Then NH4 plus means 1 electron is less in the NH4 compound. Okay. Then depending upon the bonds between the atoms, the distribute total number of electrons as bonded shared pairs. Okay. Depending upon the bonds, between the atoms, distribute the electrons for the bonded pairs. Okay. Total number of electrons for bonded shared pairs. Okay. So, third point. Okay. Fourth point, least electronegative atom occupies the central position. Least electronegative atom occupies the central position. Example, NF3. Nitrogen is least electronegative, so central atom is nitrogen. Okay. Then CO3 2 minus, carbon is at the central position. Okay. Next, fifth point. After the single covalent bond formation, the remaining electrons are used for multiple bonding or remain as non-bonding or lone pair of electrons. Okay. After the single covalent bond formation, remaining electrons used for multiple bonding, okay, or remain as non-bonding or non-bonding pairs or non-bonding electrons or lone pairs. Okay. Then shared pair of electrons are responsible for the bonding and these are called as bond pairs. So shared pair of electrons are called as bond pairs. Okay. Then what about the non-bonding? That is valence electrons not involved in bonding or sharing are called as non-bonding electrons. Not involved in sharing. Electrons not involved in sharing. Okay. These are called as non-bonding pairs or lone pairs. Okay. Non-bonding electrons or lone pairs. Okay. Now let us discuss some examples whose Levy structures are drawn. Okay. See, in the case of O3, it contains 3 oxygen atoms. These 2 oxygen are attached by double bond, then single bond. Okay. Here, this oxygen shares 2 electrons to here and this oxygen shares 2 electrons from here. So, total 4 electrons. So, double bond is obtained. Okay. Here, this oxygen contains 1, 2, 3, 4, 5, 6. This oxygen shares its both the electrons to here. So, it forms a single bond. So, 2 electrons are bonded. So, single bond is obtained. Then, this oxygen contains 6 electrons and it completes its octet by sharing the electron from this oxygen atom. Okay. Then, what will happen here? CO3 2 minus. As a result, it gets a positive charge. Here it gets a negative charge. Okay. Then CO3 2 minus. 2 electrons are extra. Okay. So, here a double bond is obtained. Carbon contains 4 valence electron. One is used here, one here and 2 electrons are used for the formation of a double bond. Okay. So, total 4 electrons. So, double bond is obtained. Here, it contains 1 electron is used for sharing from this oxygen. Here also the same case. But 2 minus, so 1 extra electron here. So, it contains 6 electrons. Here also the same happens. Then NF3. Fluorine contains 7 electrons. So, 1 electron used for sharing from here. So, all the it's the same case. Then nitrogen contains 5 valence electrons. 3 are used for sharing. Then 2 electrons remains. It remains as lone pair. Then what will happen in the case of HNO3? Okay. Here OH bond is formed. So each electron from this oxygen shares here. The nitrogen contains 5 electrons. 2 electrons are used for sharing with this oxygen. So double bond is obtained. Okay. 1 electron is used for this oxygen. Remaining 2 electrons are there. Okay. Both the oxygen from nitrogen is used for sharing. So an arrow will be represented like this. So it gets a positive charge because both electrons are shared from here and this electron used those sharing electrons and form a bond. Okay. Then NO2 minus. Here nitrogen contains 5 electrons. 1 is used for bonding here, 2 here and 1 lone pair of electrons. This oxygen uses 2 electrons for bonding, remaining 4. Okay. Here 1 is used for this bonding, this bond. Okay. So remaining only 5 electrons. But there is a minus charge, 1 electron extra. So it gets a minus charge. So it gets 6 electrons. So like this we can draw the Levy structures of different atoms and covalent bonds can be drawn.